Better late than never. Okay, obviously I'm starting very late and I doubt there'll be anybody at all awake by this time to watch my stream. Anyway, um, it's not completely bad. At least, um, getting something done, getting something done, every day is better than getting nothing done at all. So let's see. Yesterday I started going over the questions I've solved previously. Now this time around, from day 50 going forward, I want to change my the content I make here, right? I will try to understand a question, right, rather than just explaining it itself, right? I would, show you how I go about with the way. The title of this series is called 100 Days of Studying Data Structures and Algorithm rather than teaching, right? I mean, I will also be teaching, but the main point is also learning, right? So, um, yeah, and that way it will not only help me study as well while I'm streaming. It will also help me show you guys or take you along on my journey because I have been doing a lot of work during the day, so I'll just take this streaming session as my learning time as well. Okay, so let's just jump right in, and i will I will do. So there is this question I started yesterday, which is the number of arithmetic triplets. I'd already solved this question, but I used the brute force solution, right? I can show that to you. Let me show you. Um, so here's my brute force solution, right? So it's basically, let's read the question first of all and know what it says. So you are given a zero indexed strictly increasing integer array norms, right? And a positive integer diff. So I'll just call it difference, right? Now a triplet ijk is an arithmetic triplet if the following conditions are met. If I is less than j is less than k, and if norms at j is minus norms at I is equal to the diff, and norms at k minus norms at j is equal to diff as well, return the number of unique arithmetic triplets. Now, when so I mean with my first solution, right? Let's take a look at this example. So here's what I'll do. I'll take this solution. Let me take these norms here. I'll take these two inputs to explain what should happen in this question. I'll try to solve all these ones. I'll close them. So here's what we have. This is our input, right? Now we are told to find the number of unique arithmetic triplets, right? Now, for us to do this, I mean, if you read the hints, right, are the constraints small enough for a brute force solution, right? And can we use three loops? Obviously, by using three loops, right, you get three unique values at each point, right? So, which is why that will work. This problem accepts a brute force solution, but is not well optimized, or is not optimized enough for, let's say, much more constrained conditions, right? But the constraints here work fine for the brute force solution. So let's see how we can do this. So let's say we're finding unique arithmetic triplets, right? First of all, the arithmetic triplets are indexes. So it will be, you know, we'll have I'll call this ij. So here, let me use a different color, right? I so okay, our arithmetic triplets will be I J. Oh, come on, I'm using a different color. Sorry. Okay, I know what's happening. Let's come here. Okay, so we'll have I, J, and K, right? These are the triplets we want to find, right? Now, these triplets, like I said, are indexes. So 0 is at index 0. This will be at index 1, index 2, index 3, index 4, index 5. Now, our arithmetic triplets can be any of these indexes. It could be 0, 1, or 2, right? This is an arithmetic triplet. But for it to, I mean, these are 3 indexes in the array in this increasing order. So like the condition says, I has to be less than j, and j has to be less than k, right? This satisfies this condition, right? But there are 2 more conditions that makes a triplet, or that shows if a triplet is a valid arithmetic triplet or not. So the condition is such that the number at let me use a different color. I don't like the white one. The number at I, right? And let me check that quickly. Nums at j minus nums at I is equal to diff nums at k. Okay, so the number at j here, right, minus the number at I should be equal to the difference, right, or the diff, and the number at k, I'll put number at k minus number at j should be equal to the diff here as well. Now so this first triplet here, this example of triplets, right, does not satisfy these 2 conditions here, because the number at this index here, I, right, and this will be number at j, right? Number at j minus number at I here will not be equal to diff. Diff is equal to 3. So this obviously is not a valid arithmetic triplet, right? And we will need to, find those triplets in the array, right? Now, our triplets can appear anywhere, right? Anywhere in the array. It could be, this one. It could be something here, and then there's no particular order for us to find the triplet, or for us to put the triplet in, right? Now, because let's see. But one thing that helps us is we know the array is strictly increasing, right? Which means the array is sorted in increasing order, right? So for us to so if the array is sorted in strictly in increasing order, it means every item, right, in the array is superior. I mean, it's at an index superior to the previous one, right? Which means, like I said, which means this here could be our I, j could be here, and k would be here, right? This here is possible, right? So the first condition will be will work for the first condition, right? Knowing the first condition, because I has to be less than k. I mean, I has to be less than j, and j has to be less than k, right? Knowing this condition, we know if we run 3 loops, right, we'll always get the solution correctly, right? Which means if we started the first loop, if we run a for loop, let me show you this. If we run a for loop, right, which is the the outermost loop, right, the first loop, we'll target the first item first, right, and then an inner loop will be the second item, and then a third loop will start from this place here, right? So each time we'll be able to get a pair of of every three of three consecutive we'll be able to get 3 consecutive items in the array with a nested loop, 3 nested loop, right? But this solution is obviously going to be O of n cube, right? Which is a cubic time complexity. We don't even for a nested loop, right? 3 nested loop. This network is killing. Anyways, running 3 loops means we are Christ. Running 3 loops means we are always going to get this condition correctly, which means I is going to be the outermost loop, right? It's going to start from this point, right? And then we'll say 0, and then we'll look at the next number, which is 1, and then from 1 we can pair it with every other number as well, every other item starting from the kth item. So this k will start from here, so this will be 0, 1, and 4, right? This will work for a 3 nested loop, right? 3 loops nested in each other. But there is one last condition we need to check, and the point at which we check for that condition is at the 3rd loop, right? So we will then say, okay, since we've gotten all of this right, which is our first condition here, then let's try and get the other conditions as well, right? Which is nums at k minus nums at j, right, is equal to diff, and nums at j minus nums at I is equal to diff as well. So we can just simply, when we reach the 3rd loop, right, we can just write out this condition here, right? And if this condition is true, then we increment the count. Now this works again for a brute force solution, but we need to optimize our solution a bit, right, to run faster. So how do we do that, right? How do we optimize our solution to be able to at least we don't necessarily, obviously we'll have to iterate through every item in the array, but we need to reduce our solution from a time complexity of O of 3, or which is O of n cube, to O of n, right? O of n, like this. How can we do this? How can we do this? Even if it's not O of n, right? Let's come below O of cube. So I've been on the quest to find the solution, and apparently there is a trick to that, right? First of all, we need to represent every value in the array by every index, or these conditions here, right? We need to represent them with a specific equation. But before we do that, we also need to understand that our triplets are unique items. In other words, when we've chosen one item in our triplet, we don't have to repeat it, right? So every index, or I must not be equal to j, right? And j must not be equal to k. So they have to be, I has to be less than j, j has to be less than k, like this. So in order for us to, whenever we see unique items in a question, it simply means there is a chance we are going to use a data structure that lets us keep unique items, which is obviously in Python we can use a set. Now, how do we use this set, right? How do we use the set to find our arithmetic triplets? Well, our arithmetic triplet, again, let's go back and understand what it is. The arithmetic triplet. Arithmetic triplet, I'll represent it with a bracket like this. Has to be I, j, and then k, right? I, j, k. And I has to be less than j, j has to be less than k. Now, we can say for our equation, right, we can say nums at j minus nums at I is equal to diff. So nums at j minus nums at I, right, should be equal to diff, right? And then nums at k should be equal to nums at k minus nums at j should be equal to diff as well. Now we can see j here, right? If we try to find nums at j, let's represent nums by a particular number. Okay, k could be here, right? But before we reach this point, we'll start at this point. So meaning we don't know how many items we don't have. What am I even saying? Let's say we are trying to build up the triplet, right? Which is obviously going to be at unique indexes 0, 1, 2, 3, 4, and then 5, right? The triplet will be at unique indexes 0, 1, and 2 are unique, right? These are unique. 2, 1, and 3 are also unique. 3 and so on, right? Every item has to be unique. But, right, we know if we run a single loop to build this triplet, right, we'll start at the beginning here. At this point, we don't have any triplets yet. So we only have one item. Now, if we are going to continue this loop and be checking at each item, we could easily say, okay, this should be, any item in the array while we are iterating, right, should be k. We can represent that with k, or we can represent that with num, right? It could be num or k, whatever it is. It should be a constant. And since it is increasing into the array, it could be, the third constant here, which is this k here, right? And then, whenever we build up our set, right, because in each iteration we want to add an item to the set, and then we'll find out if any item in the set validates any of these conditions here. Now we can also change this to a new equation. We can say nums at j, right? We can move this here to this part, so which means nums at j could be equal to nums at I, diff minus nums at I. Let me just put it this way. Diff. Okay, let's use the second equation. Let's use the second equation. Let's say we already know k, right? K will simply be nums at j here, nums at j here, will simply be equal to diff minus nums at I, right? No, minus nums at k here. Nums at k here, like this. So we know we can substitute the value to find the nums at j, and we also know that nums at j, right, will be less than nums at k. So to find nums at j, right, nums at j will simply be the difference between sorry, when we move this to this side, right, when we substitute this, okay, that this is not what will happen. Sorry, this would have been negative nums at j, so we'll have nums at k minus the diff here instead. Yes, so this would be nums at j. So we know we can find nums at j like this, and nums, hopefully I'm explaining this very well. This question is easy, but it's a bit tricky for me actually. So nums at I could simply be, again, we know nums at j is this, right? Let's simply do this again. We can say diff nums at j, nums at j minus diff, right, for the first equation, which is this one here, and this is the second one. So we can substitute the nums at j here, right, to get I. So we know nums at j is this here, is nums at k minus this. So we can simply do nums, so this is equation 2, this is equation 2 again. Nums at j, nums at I is equal to nums at k, right, nums at k minus diff, right? So this is the first this, and then minus diff again, So this will simply be nums at I is equal to nums at k minus 2 times the difference, right, here, like this. So with this equation, right, we can represent our nums at I and nums at j with values in a set. So how do we do that? We'll build up the set, right? While iterating the array, we'll add each item to the set. So if the item does not current num, so I'll say, you see, now we'll have a common constant, right? So these are the equation we'll work with, right? This is the equation we'll work with. Sorry, we'll have this equation. So we'll have this equation here, right? And then we'll work with this as well, which is this here. So at the end of the day, we have nums at k minus diff, and then nums at k minus diff times 2, right? So so we know this is I and then this is j, right? This is I and this is j. So nums at k, we can choose nums at k as any number in the array. Like I said, we'll iterate the array and build up our set while we are iterating the entire array. And by the time we get to this point, we would have had some items in our array, right? We'll build the array regardless of whatever. So each item, while iterating the array, will represent the number at k, right? Num at k here will be any item in the array. So, and while we are iterating the array, we'll build up our set gradually by adding new values to the set. So let me show you what I meant by that. So I don't know, I'm sure my explanation would be totally clear, and this is because I just I am also trying my best to explain it in a simple way as possible, but if I did not do well, I'll try again another time and explain it better. But here is what I mean by that. Here's what I meant. So let me create an array. I'll import this here, right? So like I said, since we're asked to find unique item, right? Unique items such that we don't repeat um the indexes, right? We will simply need to build ours. I mean, we can build the set straight away, but this will cost us some optimization, right? We can simply say a set of unique items, right? Now, choosing a set of unique items simply means that we are going to remove every duplicate from the array, which is what we are doing by adding each item gradually. But this still works, but this time around, it's just going to building the set beforehand will work, right? Let me just show you that. So I'll say I'll call this scene, right? Because it is possibly I and it's going to be I or J, right? Which is going to be in this set. So set of unique item. So I'll put nums here. You know what? Let's do the first way first. Let's build the set gradually before we test out the second method. So I'll say for okay, so since I'm going to be counting, I'll put a count here to increment the count each time. So this is going to be count set to equal to 0. Okay, so for I in, so I'll just call this k. For k in range, I mean, I could use num straight away, right? Because I don't need the range for anything. So I'll just use k. But let's use range so that this is easy to understand. So let's say range len of nums. Oh, so for k in Christ, for k in range len of nums, right? Now we need to first of all check the condition, right? So we can say if k, right? If k, so we then find out about this equation. So we check for this equation. So if num at k minus diff, right? So I'll say if nums at k, right, minus diff in scene and nums at k, right, nums at k minus 2 times diff in scene, right, then we'll increment our count, right? So let's put count here, count plus equal 1. Otherwise we'll build up our set. So we'll say scene, and then we'll say scene dot add num at k, right? Now the reason why this works is for in our first iteration, right, assuming this is our array. So let me write it out again. I'll simply drag it away and then delete the rest of this. I'll not delete everything, but I don't need this part. So now, assuming we are trying to build this array gradually, now this will build in such a way that every item, right, every item in the array is going to be k. It's possibly k. Let me use the correct word. Every item in the array is possibly k. Now k is going to gradually move through k is going to gradually move through the array, right? So I'll put k like this. So k is gradually going to move through the array from this point to this point to this point, right? By the time k is at this position, we would have built a set like this. So every time we see the first item in the first iteration, right, we'll move k. After the first iteration, we'll move k. But then I also at that point we'll add this item where k is moving from to our set, right? So we'll do this. We'll say num at k is going to be 0, right? Num at k is going to be 0. So we'll add. So here's our set. So our set is going to be, I'll call this set x. You know what? Let's put the set here. I'll put it like this, right? So for this set, s is going to be this. For this set, we'll add 0 to the set. I mean, this for the first iteration, we'll add 0 to the set, right? Now, at this point, we'll check for the condition again, whether the condition is valid for a valid arithmetic triplet, right? Which is this condition here. This represents I, and this represents j, and then this represents I, from the way we transformed the equation, right? So we'll do this, and then we'll move our k to the next item. Again, that condition is not going to be satisfied for this value, so we'll put I here as well. And then by the time we get to this point, right, we'll have enough values in the set for us to have a possible triplet, right? Because at this point we can add 4 to this. This is a triplet, but this doesn't end here, right? Now, why is this not a valid triplet? This is not a valid triplet because it doesn't satisfy this condition here, right? Num at k minus diff, right, is not in sin yet. Num at k currently, oh my god, what have I done? Num at k currently is 4, right? And 4 minus diff, which is 3. 4 minus 3 is 1. Yes, 1 is in our array, but is also 4 minus 2 times 3 in the array. 2 times 3 is 6, minus 4, that's -2, right? Is -2 in our set currently? No, -2 is not in the set, so we don't begin counting this triplet as an arithmetic triplet, right? So we continue our iteration, and we keep adding values to our array, right? We keep adding values to our set, sorry. So we'll move this k to the next item, which is 6. Then we'll calculate again. We'll move to this point as well, which is 7. We'll calculate again, and by the time we're at 7, our set will be looking like this. We would have had 6 here, and then it's only after we move from 7 we'll add 7 to the set. But if we do 7 minus 3, right, this is equal to 4. 7 minus 6, right, because this for the second condition, which is for I, is 1. These two values are already in our set, right? And then you can see how they are arranged. They are arranged in different positions. These two values are already here. So because these two values are already here, we can count this one as a valid arithmetic triplet. So we'll increment our count by 1, right, plus equal 1, which is what I did here. So this is the first arithmetic triplet that we've seen at this point here. So we'll do the same thing. We'll continue incrementing. We'll move this to this point, right, and then we would have added 7 to our set, right, and then we'll calculate again for those two conditions, and so on until we are done iterating the entire array. At this point, if we do 7 minus, so at this point we're at k is equal to 10. So 7 minus, sorry, why do I keep saying 7? So I'll remove all of this. I'll remove my old calculation. So count would have been 1. We've counted 1. So moving k to the next item here, our set will be like this. Our set will be looking like this. So we'll have 7 here. So 7, Christ, 7. Now, as you can see, 7. As you can see, our set will be done building at this point because we've reached the end of our array, and this shows where k is currently. The index at which k appears is superior to every index of each of these items in our set here, which satisfies the very first condition. So let's see if so k will be 10, right? 10 minus 3 is 7. Now is 7 in our set? Yes, 7 is in our set. So this condition is valid for the first condition. So we'll calculate the third one, right? I mean, for the second condition, we'll calculate the second condition for I, which is going to be 10 minus 2 times 3, right? 10 minus 2 times 3 is 4. So is 4 in our set here? Yes, 4 is in our set, and we increment our count by 2 again. So we found our arithmetic triplet by just using a single loop, but we are using a set. And then this, to me, this is the best way I can optimize this solution, right? So I'll run this in LeetCode now and see what the outcome is. I struggle to explain this question, which simply means that I still need to come on. What have I done? I don't know. Okay. Which means I still need to properly understand the question very well. I understood the question, all right, but explaining it has to be seamless, right? Explaining it has to be seamless. So let's run this and see. None is not of type integer. Wait, hold on. What's going on here? So I did not even return anything. Christ. Return the count. Sorry. Need to return the count at the end of the day. Yes, you can see this solution works. So I'm trying to understand if there truly is a trick to questions like this, right? When you are asked to find triplets or pairs of items, right? One thing I've really discovered now is that if the question asks to find unique items, right, there is a chance for using either a set or a dictionary. Not really sure, but yeah, I will have to solve enough questions for me to actually understand this, right? So, I mean, it took me a while to understand this question, which happens every day. But um, the point is recognizing patterns, right? Which I am still yet to know how to do properly. Otherwise, yeah, the question has been solved. Hopefully, I tried my best explaining uh how the optimized version of this question. Um, anyways, it's been good. I'll see you guys tomorrow. Cheers. Let me push this to GitHub. I think I've done the question before, right? Which is arithmetic sum. I think it's in an arrays. Arithmetic sum contains duplicate to some. Wow, where did I put it? Anyways, I don't even remember. What number of question is it? Arithmetic sum is 2367. So I'll do that. It's almost 12 p.m. here. I mean 12 a.m. Sorry. Two. I'll say lit dash 2357, right? 2367. 67 arithmetic triplets. So here it is. Okay, I'll put finally ransom is here. Wow, it's been long. How are you doing? Yeah, I'm good. I'm good. And you? Right, I was just about ending the stream. It's almost 12 a.m. here, which is very late in the night. So yeah, git add. Let's push this to GitHub. Git commit dash m at met at. I don't. How do you spell that? Yeah, arithmetic triplets. Triplets. Arithmetic triplets. I'll say optimized. Optimized like this. And I'll push this to GitHub. Please push origin main. Oh, nice. Wow. That's really good. Anyways, I started this stream very late today. It's been a while since you came to the stream, and it's a pleasure seeing you again. I hope you get safe. You get to where you're going safely. Sorry, and yeah, safe journey. And I'll see you tomorrow. Bye.